Okay, guys, I think we can start the session. 1 second. Okay. Yes. So we will be continuing the things that we have discussed last class, which is Rose Movie 2. Okay. So yesterday it was just an introduction about movie 2. Like what are the things that we can do. Like if we take Rose Movie 1 and 2, we can see some similarities in the workflow, like mainly the setup assistant, all these things are the same. And even for working with the robot, like we have the RVs plugin, so you can interact with the robot, all these things are the same. So what are the differences? Okay, so what are the main differences in movie 2? So that is what we are going to see today. So I have set up a demo as well today to show you the Move It and a Gazebo interface, and also some programming examples as well. Okay, so let's get started. Before that, I just want to just clear something here. Hello, Move It. Okay, Move Trash. Fine. So I'm following the official tutorials of Move It. There is no other things that I'm taking. Like if you take the Movie 2 documentation, I mean it's there. I mean everything is there. So first is the tutorials, then how to guides, then concept, examples. All the things are there, and there is a table of content which is more useful. So yesterday we have seen the concept. Okay, it's mostly the same like the Rose one. Today we are planning to discuss about the programming API. Okay, so that is what we are going to see today. Okay, so regarding programming, so what is Movie 2 APIs? So I can give you an idea about it. Let me take, okay, so if you take the examples here, you can see the programming using Move It with two programming languages, which is C++ and Python. Okay, so I'm not sure you work with C++ Move It interface for Rose 1 Move It 1, but I mean there was a Python interface as well. It's called Move It Commander in Rose 1 Move It 1. So there are some changes in the API for Move It 2. Okay, the Move It API for C++ is almost the same for Move It 2, but they introduce another set of functions called Move It CPP. Okay, Move It CPP, and instead of Move It Commander, which was the Python interface for Move It 1, they introduced Move It Py. Okay, so these are the two changes that they introduce. Unfortunately, the Move It Py is not available in Humble. I couldn't see the Python API for Move It for Humble, but for the latest version it is actually there. So you will get the example from here itself. So first you can see the Move Group Rose Wrapper C++, okay, which is the old API, okay, which is the old API, and you can play with this example. I mean it was also there with Rose 1 example. So we have been using this API in Rose 1 as well. So that is also available in Move It 2. Okay, and the second one is this one, Move It CPP. Yeah, this one, Move It CPP. So this is the new one that they have created, which is I mean it's a different API. So you can see here this paragraph. It is not the full replacement of existing Move Groove API, but they are recommending this for advanced users needing more real-time control for industrial application. Okay, so Move It CPP is a new interface. Okay, we have the Move Group API as well, but this is mainly for some real-time, I mean more advanced users. Okay, and there comes the Python API. Okay, so we know there was MoveIt Commander, which was actually a module in Python, MoveIt Python module. But MoveIt Py is a different module in Python, and which is completely in ROS 2. Okay, and I mean, it's not like the MoveIt Commander. So you can see some code snippet here. You can initiate the MoveIt Py, and then we can give the planning group name, and then you can start planning. Okay, you can start planning like this is the function to start planning and to execute this. So there are two main things happening for MoveIt. One is the plan and one is the execute. So this is what we have to do to motion plan and execute in the robot. Okay, so those examples are given here, I mean the APIs, and this is not available, I think, for Humble. Maybe you can also have a check in the repository. If you just check, you can't able to find MoveIt Py, so just search for ROS Humble. I couldn't find it, but let me check it again. So if you just go through, there is no MoveIt Py. Okay, yeah, okay. So but for the latest version of ROS, which is ROS Iron and the rolling, it is having that. So that is the three ways of programming a MoveIt based robot. Like one is the primitive move group API that we have already used with MoveIt 1, and second is the new API called MoveIt CPP, which is not a replacement for move group API, but which can be used for like some real-time applications. And next is the API for the Python. Okay, so they have given some example. Maybe I can directly start from the MoveIt CPP. The move group APIs are not working in my PC, but MoveIt CPP APIs are working. So they are giving a launch file to start some program. I mean, the program is already there. Okay, the demo program is here, and this is what it is executing. Okay, this is the code that they are executing. I'm not describing about the API. The APIs are simple. The main thing is that it will be giving a provision to put the goal position, and then there is a API for planning, and then there is an API for execute. Okay, so the APIs are already there in the API documentation. So if you simply click it, you will get the API documentation for C++ and Python. Okay, it is there actually. So let's start with the MoveIt CPP demo. So like if you simply run it, one second. This is a demo for MoveIt CPP, which is the new C++ interface. So here what happening is that there is a node. Okay, there is a node running in the background. The node is already mentioned here. Okay, this is the project that we are working on. This is the source code. Okay, I'm just so just make it as Humble, and this is a code that we are running, and the project is already here. This is a MoveIt _CPP package. Okay, you can simply copy it, and yeah, and this is the launch file that we are going to run. Okay, and so let me take the CPP code again. So basically it is a ROS 2 Python C++ node, and it is simply taking the Panda planning group. Okay, Panda ARM planning group. Planning group, I think you already know, like in the setup assistant, we are creating the planning group, right? We can name it. So currently the example they are using is Panda. So that planning group named is Panda ARM. Okay, and then what they are doing is they are triggering each section based on the visual tool that I can show you. And so maybe you can see here this GUI. Okay, so the program is written in such a way that if you are pressing next button, okay, it will be executing one section like that. Okay, so I'm pressing next. So you can see on the top there is a RVis marker which is called Move It CPP demo. So I'm going to press the next button. So you can see set start state to current state. Okay, so when you press the next button, you can see each functions. Okay, so this is setting the start state, like they are using the robot state from one state to another. So here you can see start position was this, target position was this. So they have created a plan, and this is like start position is this, target position is this. So they created a plan out of it, and this is again like from the start position to a named state, like it is showing the plan mainly. Okay, so this is like planning around collision. Okay, so it is actually demonstrating different different routines. Okay, we can run it again. So the demo basically for demonstrating the features of the API. What are the things that we can do with the API? So like maybe I can do this loop animation so you can watch it again and again. It is like a plan, you can see. Okay, so it's actually giving different target pose, and it is moving to that. Okay, the solution is fast as well. You can see it is very fast. Okay, fine. And they are also putting the API for Move Group, which is the API for ROS1. But unfortunately, the example for Move Group is not working in my system. So you can also try that. Just click Move Group C++ interface, and you can try to run it. Maybe I can try again. So this is example, and let me see whether it work or not. Okay, and I'm starting the next terminal. Oh, okay, now it's working. So it is similar to the Move It CPP demo. You can press the next button and you can see the same stuff. Okay, so that means we can do the same stuff using the different API. Okay, but from my observation, the Move Group APIs are slightly slow compared to Move It CPP. Okay, I think that's it. Yeah, I think that's it. There is no other action going on, I guess. Yeah, I think there is no other thing going on. Yeah, so these demo you can also try on your machine. Let me just try to rerun it. So the example is already there, just under the link. You can check that. So this is the Move Group API that we already practiced. The same thing, different. So I'm not explaining it. You can just have a read. It's not that difficult. I'm just running the example. Okay. Okay. Now starting the node. Okay. Now we can start the Avis and yeah. So loop animation. Yeah. So this is a join space goal. Join space goal means it is we are sending the join state or join values, not the end effector value. Yeah, I think these three demos are there only. Okay, it is demonstrating. Okay, okay, so we can close it. Yeah, so I just want to show you the final demo. So these two things are with the programming. Okay, there is not much changes happen. Like you can use the move group and also the move it CPP and move it Python. Okay, so we can see the last example, which is a demo, which is connecting Gazebo and move it. Okay, so Gazebo as the controller server and move it as a controller client. So when you press the execute button, it will be executing in the Gazebo. Okay, I will explain it after that. So it is a robot that I have did, which is let me try. I just set it up. Let me see it's working or not. Yeah. It's still showing that error. I'm not sure what happened. This is an existing package, by the way. So this is the Gazebo. We are just starting. Let me see. Yeah, I think there are some issues here as well. 1 second. Let me start it. Okay, I think it is crashing somehow. Let me see. Yeah, let me see. Like we can run it at the end, maybe next class or something. There are some issue with move it, I guess. Okay, so maybe next class I can show you the demo clearly. Yes. So regarding the move it, the main thing that we want to discuss was like first it was like an introduction, what is move it and how to create the configuration package for move it. Okay, and then we will be seeing what are the programming interfaces that is available. So we have seen the examples. Okay, so you can create a package by your own, and then you can move the robot programmatically. Okay, so this is the first project that they are mentioning. Okay, so basically it is using this is basically using the move group interface, you can see here. Okay, so like we have done in ROS 1, and yeah, so that is the thing. And the final thing is the connection of move it to Gazebo and adding controllers, all this stuff. So we have seen the movement of robotic arm in Avis using the motion planning plugin. But if you want to move the robot, actual robot or the simulated robot, you can simply change the configuration file in the Move It, and you can simulate a robot. Like after planning motion, doing the motion planning in Arvis, you can send that trajectory into uh, simulators like Gazebo, then Isaac Sim, web boards, all these things you can do. Okay. Yes, so that was the objective of this chapter. Okay, mastering ROS Move It. And let me see, like for the demo I can show you the other stuff, like I have added a vision camera into the uh, Move It package, but unfortunately it is not it is not working. Okay, so let me see whether it's a problem of VMware. Okay. Yes. So yes. So we can, I think, conclude for I mean this chapter we can conclude. Uh, I will be discussing the demo and also some other topics maybe next class after setting everything up. And now we can just start with an introduction to the navigation stack. Okay, so we can discuss a very brief idea of navigation stack, and then next class we will be discussing some demos, then in detail we can explain. Okay, so I will be taking like 15 minutes or so, and then we can just go through the navigation stack. So as you know, the navigation stack, Move It, then the perception are the three important capabilities in ROS. Okay, so uh, out of these three, I will say navigation stack is the famous one, because there are a lot of wheel robot applications. I mean, can be done using this. Obviously, we can do manipulator application using Move It, but I am thinking like more than manipulator application, the wheel robots are everywhere. Okay, so yeah, so the Nav 2 is a successor of navigation stack in ROS 1. Okay, and the concept wise there are some changes, and they have given the architecture and all, what are the differences, all those stuff. Okay, and in this website they also mention how to set it up, all these things they have mentioned, and also they have mentioned the concept, programming, API, all these things. Okay, so we will be like seeing some basics, and then we will be concluding. So this is architecture I just want to discuss first, and I also want to take um, the architecture of the old navigation stack. Okay, we can simply compare. So this was the old navigation stack architecture. Okay, you can see it, right? So in old navigation stack, it was actually a single program. It's called MoveBase, and the MoveBase was a main node, and a lot of plugins are loading into the MoveBase, like global planner, local planner, global cost map, recovery behavior, local planners are all plugins. Okay, so it's a single node. Okay, and if you can check, the only input means only input from the user is this goal position. So simply you can send a goal position to the navigation stack, that's it. Okay, and it is taking the other inputs, sensor inputs, like laser scan, point cloud, then other data like map, then odometry, TF, all these things. Okay, and what is the output? The output will be the command velocity. okay, command velocity to the robot controller, then the robot will be moving. Okay, so that is the main thing in the navigation stack. So what about navigation stack 2? So basically there are a lot of things changed. Okay, so what was the purpose of this change? Because because the change was to improve the navigation stack, of course, right? So what are the improvement what happened in the navigation stack 2? So basically instead of the move group, okay, instead of move base, instead of like running a single node, currently we have multiple nodes, okay, multiple node in the form of like plugins, okay. And I'm not sure you heard about it's not like plugins, it's node itself, but in ROS 2 there is a new feature called lifecycle manager, okay, lifecycle nodes. So all these things are lifecycle nodes. So what is a lifecycle node? A lifecycle node is a node which can control, we can control the sequence of execution. For example, you run a node, and the ordinary node, when we start, it will be start running, right? But the lifecycle nodes are not like that. We can command the node to start, then only it will start, okay. And once it start, if you command the lifecycle node to stop, it will stop. So there is an option to change the state of the nodes. So that is the lifecycle node. So the lifecycle manager is a program which is loading the lifecycle node. Okay, so all these things inside these blues are lifecycle nodes, and you can see these lifecycle manager program, which is actually from ROS 2. They have written a lifecycle manager for ROS navigation stack. And what are the lifecycle nodes that is running? There is a node called BT Navigator Server, then Controller Server, Planner Server, Behavior Server, Smoother Server, then a Route Server. So there are multiple servers, and the Behavior Tree Navigator is communicating to all these server. And the inputs are like waypoint follower, autonomy system. Then the output will be the controller will be sending to the velocity smoother, then to the collision monitor, and then to the robot base. So there are multiple blocks actually there in the navigation stack 2. So what's actually changed is that if you check the inputs to the navigation stack, currently the user input is not a single goal position, but instead of that you can give a waypoint, set of waypoints you can directly give. And that is not the main change actually. The main change is that if you just check the navigation stack 1, you can only just send the goal position. There is no technique or methods to give a sequence or some kind of behavior in navigation stack 1. Behavior means if the robot reaches this position, do this. If it is successfully reaching it, then do this. So kind of state, okay, state machine kind of stuff. Like you maybe heard about the state machine, right? The state machines are like you can create a set of state, and the robot will be going from one state to another. Each state will be some kind of task or action. But if you take the navigation stack 1, there is no state machine inbuilt, okay. So there is no inbuilt facility to command the robot to some position and do some stuff. And literally there is no provision to orchestrate the robot movement. Orchestrate means if you want to do a particular task, for example, go to the grocery shop and pick an object from some specific shelf, then bring into some position. So if you want to program in navigation stack 2, you have to write a code to command the robot to specific goal, and after that you have to you have to create a code, maybe using finite state machine or your own logic. Okay, but in navigation stack 2 it is different. Okay, it is different. It is having an inbuilt feature called behavior trees. Okay, it's a very important feature in navigation stack 2. Basically the behavior trees are like these kind of orchestration. Like you can create a set of state. Okay, maybe I can take the official website of behavior tree. Like you can create a sequence of action. Okay, like close the door, walk. Okay, so all these things you can actually do. You can build it in the navigation stack itself. So that's a big change, right? So it is, it is very useful to create an application, and it's very useful to create an application, autonomous application. You don't need to write separately. It's all there inbuilt. Okay, and if you check the architecture again, everything is modular. The controller server, from the name itself you can understand, the controller server is having the controllers. Okay, controller, then it is having the local course map as well. Then in the planner server it is doing the planning, like global planning and local planning. Then the behavior server, it is actually working with the behavior trees. Then the smoother server, it is smoothing the trajectory. Okay, then root server, I think I'm not very used to this, but mainly these four stuff. But these behavior tree, BT navigator server, is the main key here. You can feed a BT. Okay, you can feed a BT, that is behavior tree, and the robot will be moving based on the BT instruction. Okay, so the entire navigation application can be compressed in a BT. Okay, in the behavior tree. So we don't need to write additional stuff. Everything can be done with the navigation features. Okay, and each servers are independent. Okay, and if any of the server is crashed, then the entire nodes will be shutting down. So that is actually for the safety, and you can enable, disable each server if you want to enable each module, so disable each module, you can do that. And one of the problem with the navigation stack 1 was you can't able to change the planner or controller on the runtime. Runtime means like if the robot is doing some planning from A to B, if you want to change the planner dynamically, you can do that in RVis1 nav2. Okay, but not in nav1. Okay, so there are multiple features in navigation stack 2. So I'm just giving an abstract of this. There is a video. He actually, the author of nav2 is Steve McKenzie. So he is mentioning the complete details about navigation stack 2 here, and also mentioning the other projects, like in order to do the mapping, we have the SLAM toolbox, which is integrated in navigation stack. Then we have the AMCL for robot localization, then the behavior tree project for creating the behavior tree. Okay, so all these things are there. There is a IEEE paper as well for I mean that is discussing about the navigation stack 2. Okay, then we have the tutorial. All these things we can see next session. This is simply a basic I mean we are discussing the basics only, and the installation of navigation stack is very easy only. Like you can simply execute this command. So like ROS humble navigation stack 2 will be installing all the navigation stack 2 packages. Then now to bring up then if you install the Turtleboard 3, you can start working on some demos. Okay, so if you take the installation, you can see a Turtleboard 3 demo. We already seen the Nav2 demo before, but I think we can check it again. Then yeah, this is for the installation. Installation is pretty easy. Like if you just check the Synaptic Package Manager, simply search for navigation stack 2. I think it's already installed. Navigation 2. So this is the main package. Okay, so if you installed on your machine, it will be setting up everything. Okay, that package. And importantly, the navigation stack 2 is having I mean it is having many things, and they are mentioning the tutorials for plugin writing. So I mentioned that in navigation stack 2 we have the server. I'm not sure you clearly understand that the server means action server only. Okay, action server. In ROS we have action services, topics and all, right? So all these are action server and communicating through request and response feedback communication. And inside this action server you can have plugins. Okay, so these plugins we can actually create. Okay, you can actually create it, and you can switch these plugin dynamically as well. So that is what this plugin tutorial discussing. Then in the configuration guide they are discussing about how to configure the behavior tree, then the planners. There are different planners available, then AMCL, all these things, the configuration value. Like if you remember, like in ROS 1, if you take the AMCL wiki page, you will get the parameters and all, right? Like if you take the G mapping, you will get the parameters. So this is that only. Like if you take the if you are planning to use navfn, which is already there in ROS 1, this page is actually mentioning the values and its use. Okay, so that is a configuration guide. Then tuning guide, obviously, like when you start working on the robot, what are the fine tuning that we can make to make the navigation perfect, which is this. And this is for the behavior tree. Okay, so how to create the behavior tree, all this stuff it is mentioning. Then this is again for the navigation plugin. So they, in this section, they have listed down various plugins present in navigation stack. So like what are the different plugins that we can use? That involves planners, controllers, course map layers. All these things are already available. Okay, different plugins are available, so you can use that. Then this is for migration, like from navigation stack 1 to 2. And this is for commander. Like it's very easy only. Like if you want to move the robot from a Python program. Okay, I think we have done in ROS 1 as well. Like if you want to trigger stuff, the navigation using a program, we have the basic navigator module. So using that you can simply command the robot. Okay, so that is the basic idea of the tutorial, official tutorial. Next class we will be seeing some behavior trees example and also somewhat deeper concept of each modules in the architecture. And let me see if we can run some demos. We already seen the Lino board, right? So we can try to run the Lino board again to see whether it's working or not. So Linobot is one of the project that we can take for a reference. So let me just start the Linobot simulation. Fine, gazebo. Okay, let me start the gazebo. Okay, it is not getting it. Maybe I have not sourced the path. Let me see. Yeah, I just disabled that. That is the reason. Okay, let me just try again. So let me start the gazebo. Let me just close it and take it. It's showing not available, but okay. Let me take it again. So I'm starting the gazebo and starting the navigation. So it's based on that commands in the GitHub. So this is the Lino board, and let me see whether I can start the navigation or not. Okay, so this is loading all the servers, and let me start the visualization. It's waiting for the AMCL to be ready, so we have to start the visualization and then give the initial position, it seems. Yeah, so I'm just giving the 2D pose estimate. Yeah, so you can see the navigation just started. I mean, it is active, and now you can give a 2D nav goal. So you can see the robot just created the path. So what we are seeing is the basic use of navigation stack. Like we are simply giving the goal position and then the robot is reaching that. But the actual purpose is not like that. We have the behavior trees, which is actually which is the game changer. Okay, so on the RVs you can see here the navigation, localization, feedback. So this means that all the nodes are active. Okay, but unfortunately it will take a lot of CPU to get working, so that's why it is crashing. So maybe like if you are working with a environment which doesn't have much components, then the processing will be much better, I will say. But in this environment there are multiple things, right? So I'm just closing everything. Yes, so that was a small demo of navigation stack 2. So next class I am planning to discuss some concept deep concept about the navigation stack too, and you will be getting introduced with the mostly with the behavior tree demo. Yeah, so that is the objective, and I will be trying to showcase with a movie demo. Today didn't work because of some reason. Okay, yes. So that's it for today. So if you have any question, let me know, guys. And like if you want to discuss any more concept, let me know. Next class we will be focusing on the navigation stack 2 again, and maybe somewhat about the deep learning. Let me know if you have any questions.
Sir, no questions for today, but I have a request for the next class. Like, if you can give us an idea, like how we can write the custom
Yeah,
plugins,
yeah, yeah, yeah. Yes.
like similar to
Yeah,
Gab.
yeah, yeah. So
Yeah,
maybe.
not just
Yeah,
an
yeah, yeah, I
idea.
will
Like,
try. I will try. So, Kuljit, the thing is that the main thing that we are doing with the navigation stack is creating the behavior trees. Like, if you want to orchestrate the robot movements, like do this, do that. If it is failed, do this. So, behavior trees are the important part, and the next is the plan. I mean, plugins. Plugins means that like you can create any number of plugins to enhance the capabilities of the navigation stack. So I will be discussing how to write it. Okay, so that I can give you an idea. Okay. Okay. So if you don't have any question, we can wrap it up. And yeah, so next week I will be announcing the class timing, and maybe if I can take Sunday also, maybe next Sunday I will announce that. Yes. Okay, okay, guys. Thanks for attending. See you in the next class.